Alright guys, today I wanted to talk a little bit about the M29 Weasel tracks and kind of my designing process, what I think when I go through and design all this, and I hope I can explain well enough, and if you guys have any questions, make sure to leave a comment. But anyways, this is what I came up with for the individual tracks. I knew I wanted to use C channel. Trying to replicate the original tracks, I'd have to cut out a bunch on the plasma table and bend things and weld ribs on, and anyways, it just wasn't logical. And so this allows me to just buy 4-inch C channel, which matches the width of the individual tracks on the Weasel now, and then I can cut them to length and throw them in the plasma table to cut all my holes out and cut these legs so that they have these individual teeth. And I did that because this is going to be used primarily in the winter, and with it being used in winter, there's going to be a ton of ice, and you don't want to start sliding in a Weasel because you can't stop yourself. It's not like you're in a dozer or an excavator set where you can throw your bucket or blade down and stop yourself. So that's why I designed these teeth in it. And once I got this designed, I moved on to the track guide itself. And this was a little bit more difficult just because I was trying to think of how I was going to manufacture this. So at first I was trying to design something for steel, but I kind of had an epiphany on this new filament I've been using from Bamboo. It's a PHT-CF, which is just a carbon fiber nylon filament. And I had printed angle grinder guards and things like that, and I've dropped and abused those, and they've held up really well and haven't broke. So I went ahead and 3D printed one of these, and if those of you that watched the destruction test that I made, it held up to 3,000 pounds of force, and that really impressed me. The only problem is these jigs that I printed to help me clamp onto it ended up sliding off, so I never actually broke one, which also impresses me, but it did withstand 3,000 pounds of force right in this midsection here. So anyways, once I printed that, decided that was going to be my option, I still wanted to have a backup plan, just because if I do have a catastrophic failure down the road, I've already put in place a backup plan to where I could quickly make something else and pull the tracks off, pull the guides off, and replace them. And this is what I came up with. So this is going to be a 3D printed, again, out of that carbon fiber nylon, just a die that allows me to use the plasma table to cut out a plate and then press it into the shape I want. And I think it's going to work really well, but again, this is still more labor than if I just 3D printed all of them, just because I'll have 4 seams to weld, and then I'll have to weld it onto a base plate. So anyways, I'm going to come back to this if I have to, but I really do think those 3D printed guides are going to work just fine. I just don't know for how long. But anyways, once I got those individual tracks designed, I wanted to model it up. And the reason I wanted to model it is because if something's off, it's going to show itself with where these individual teeth are meeting the track. And sure enough, I modeled this up based off of the 3/8 conveyor belt, so the spacing in here being 3/8, and they were not meshing right. Only one tooth was engaging on one individual track at a time, and ideally you want it to be engaging at least 3 of the individual tracks, and it wasn't doing that. So that's why I wanted to model these things up. That's because down the road I don't want to run into these problems. So I ended up putting it back up to that 1 inch of gap, and everything lined up perfectly how I wanted it to. But I'm running into a problem where the rubber on the sprockets and the bogey wheels are shot, so I got to replace them anyways. And since I'm 3D printing things, I was thinking about using just a high density rubber filament, like a TPU 95 from Bamboo or something like that, and just doing a high infill with lots of walls just to make it a really firm rubber replacement for what's on there, but it also allows me to make it thicker. So since the rubber on the tracks right now, the original ones, is about 3/4 of an inch, and the conveyor belt's only 3/8, I can just make the new rubber on here 3/8, and then it'll get me to that 1 inch of spacing. So anyways, that is the modeled tracks, and now I needed to cut it out on the plasma table, the C channel at least, and this is what I came up for a jig. So the plasma table has a bunch of flat bar that's all curved inside the plasma table, and I'll show you guys that in a minute. But essentially I 3D printed some legs on here that has a bolt that goes through the top. It allows this to swivel to match the curvature of the flat bar. Then it has a set screw that pinches onto the flat bar, securing this whole base plate in place. And then I went ahead and designed just a couple slots for the C channel to go, with the first one allowing the plasma table to blast out these top holes. I also included some holes here that I tapped and put a bolt in just to lock this C channel into place. And then my thought process behind here was to have a tapered opening, that way you can slide it all the way back, kind of wedges into place. And then on the front side I was going to put a vice grip to hold that into place. This didn't end up working because it's too tall. I thought I had cut some 4-inch tube out on the plasma table before, but I guess I haven't, and the gantry can't go over top of this. So I'm gonna end up having to make another jig that I can pull the flat bar out of the plasma table. That'll give me an extra 3 inches I can drop this jig down into, allowing me to cut out these legs, which again I think is super vital for if you're going to be dealing with ice. And we also wanted to shorten up the length of the legs, the legs, as opposed to trying to find some specialty C channel. The legs as they were 1.5 inches, and that would just, as a grouser on a track system, it's just too much. You're going to end up tearing up the ground. If you're not going to be in snow a bunch and you do end up driving around the house or something, it would just really tear up the ground. So that's why we wanted to cut the legs off. Other than that, I did design these little tabs on 2 sides, and that's because my plasma table has a laser, and that allows me to put that laser right on that crosshair and align the corner of the jig. And then I can take the laser up here, align onto this line the laser, and that aligns the edge of the jig, which squares my whole X and Y into the program on my plasma table. And so that just allows ease of use. Once I get this set up, I can just start running C channel in it, blasting it out, pulling it out, putting a new one in, and just doing that repeatedly. But I'll show you guys real quick the plasma table and kind of show you how the jig actually turned out, and kind of what it did and how well it worked. Alright guys, so this is the jig that I was showing you in the program. So it worked out great. It allowed me to cut all this out rather quickly. You can see here, got all of the C channel cut out. Well, not all of it. My blade was shot, so I had to get another blade that just came in today. So I'll get the rest of this C channel cut up and turn into some track pads for the Weasel. But you can see there's the crosshairs that I put on to allow me to line up the whole jig in the program on the plasma table. And yeah, it just allowed me to cut the stuff out pretty quick. But yeah, I just wanted to show you guys just my general thought process on how I go about designing these things. That way I don't have as many problems down the road. I used to do a lot of cardboard CAD and cut stuff out by hand, but now that I have a plasma table and the know-how to utilize Fusion 360, it just makes sense to figure out problems now instead of dealing with them later and having to get even more custom on things. So anyways, thanks for watching, and I'll see you guys in the next update.